All right, let's dive into one of the most famous and, frankly, weirdest ideas in all of science, Schrödinger's cat. You've probably heard the name, right? It's this wild thought experiment that brings together quantum mechanics, a genius physicist, and, of course, one very famous but totally hypothetical cat.
So let's just get right to the heart of it. Can a cat be both alive and dead at the exact same time? I mean, your gut reaction is no way, right? Seems completely impossible. But when you step into the bizarre world of quantum physics, the answer gets, well, let's just say it gets really, really complicated.
Okay, and right up front, let's be super clear about this. This is a thought experiment. No cats were ever actually put in a box or harmed in any way. Phew. It's basically a story, a really clever mental tool that a physicist came up with to try and poke holes in the strange new rules of quantum science.
So to really get what this is all about, we've got to rewind a bit. Because this story, it isn't really about a cat in a box. It's actually about a huge, high-stakes debate that was going on between some of the smartest people on the planet about what reality even is.
So picture this, it's 1935 and the world of physics is kind of in chaos. Albert Einstein helps write this paper, the EPR paper, that basically questions everything about the new field of quantum mechanics. This gets him talking with another physicist, Erwin Schrödinger, and they're both super skeptical. And it's right in the middle of this intense back-and-forth debate that Schrödinger's famous cat idea comes to life.
Now, the core idea they were wrestling with is something called quantum superposition. And get ready, because this is where your brain starts to melt a little. It's the principle that a tiny little particle, like an atom, can be in multiple states all at the same time. It's not this or that, it's kind of both, at least until we look at it.
Okay, here's a pretty good way to wrap your head around it. Think about a spinning coin. While it's spinning in the air, is it heads or tails? Well, it's neither, and it's kind of both, right? It's just a blur of possibility. That's superposition. And the moment you measure it, when the coin finally lands, it's forced to pick one, heads or tails.
All right, so now that we have that spinning coin idea, that superposition thing, in our heads, let's peek inside Schrödinger's infamous box. We're gonna see exactly how he set this whole thing up to take that weird quantum rule and push it to its absolute breaking point.
So here's the setup he imagined. First, you've got a totally sealed box. Inside that box, you place a single radioactive atom. Now, this is our quantum trigger, right? It has a perfect 50-50 chance of decaying over the next hour. Next, you rig up a deadly mechanism. If that atom decays, a Geiger counter will detect it, and that triggers a little hammer to smash a vial of poison. And then, you place a cat inside the box. Its fate is now completely 100% tied to that tiny, unpredictable atom. Okay, so we have the setup. Now, what happens when you actually apply the rules of quantum physics to this whole situation? This is the moment where the super weird logic of the tiny, subatomic world crashes head-on with our normal, everyday reality. And the result? It just doesn't make any sense. Now, to really get the punchline of this paradox, you need to know what theory Schrödinger was arguing against. It was called the Copenhagen interpretation, and it was the leading idea at the time. It basically said that, on a quantum level, things stay in that fuzzy, all possibilities at once state until you observe them. The simple act of looking or measuring is what snaps reality into a single, definite outcome. And this is where the whole thing just goes off the rails. According to those Copenhagen rules, that single atom is in a superposition. It's both decayed and not decayed at the same time. But because the cat's life is tied directly to that atom, the theory implies that the cat itself, this big living creature, must also be in a superposition.
And there you have it, the final, logical, and completely absurd conclusion. If the atom is both decayed and not decayed, then the poison is both released and not released, which means the cat, locked away in that box, must be in a state of being both dead and alive at the same time. A quantum zombie cat, essentially. But here's the big twist, and it's a really important one. Did Schrödinger actually believe that a cat could be in this impossible state? Absolutely not. The whole thing was a trap he was setting, and now we're going to talk about what he was really trying to do.
The whole point of the story was to sound completely ridiculous. He never ever thought this could actually happen. He was using this absurd image of a half-dead, half-alive cat to shine a giant spotlight on what he thought was a huge flaw in the Copenhagen interpretation. His logic was simple. If your theory leads to a conclusion this crazy, then there must be something wrong with your theory. So let's just break his real argument down. This whole thing was an attack, plain and simple. He was essentially asking, okay, so where's the line?
When do these bizarre quantum rules just stop working? Because surely a big thing like a cat has to be one or the other, alive or dead, whether we're looking or not. To him, applying the rules of a single atom to a whole cat was just a bridge too far.
And he wasn't the only one who felt this way. His friend Albert Einstein absolutely loved this example. For Einstein, it perfectly captured the problem he had with quantum theory too. This massive, unexplained gap between the fuzzy, probabilistic quantum world and the solid, predictable reality that we all live in.
Okay, so if the whole experiment was just Schrödinger's clever way of making a point, why on earth are we still talking about it nearly a century later? What is it about this story that gives it such staying power?
Well, it's because this little story perfectly illustrates something that physicists call the measurement problem. And honestly, it's still one of the biggest unsolved mysteries in all of science. It's this question: if the quantum world is just a haze of possibilities, what is the thing that forces it to collapse into the single reality we see? Is it the act of a human looking? Is it the Geiger counter? Is it the cat? We still don't really know.
And that right there is why this story is so timeless. It's probably one of the most brilliant thought experiments ever. It acts as this perfect bridge connecting our normal world to the absolutely bonkers world of quantum physics in a way we can all kind of grasp. And it makes us ask these huge, fundamental questions about the nature of reality itself.
So it leaves us with this one final, mind-bending question to chew on. If the act of observing is what snaps reality from a blur of maybes into one single is, then what does the universe actually look like when nobody's looking?